Hello everyone. We will start in a short while. I think there are lots of people already logged in. So today's class is for triangles revision. So we'll try and revise triangles. And if you have any query, you can always post it in. Just for a confirmation whether you guys are able to hear my voice, so you can just reply back in the chat section. So that I am aware that you guys are there and you can hear me. Is there any problem in viewing the slides and all? Are you able to see the screen? So I have shared my screen with you guys. So if you're not able to, then let me know. Hello everyone. We will start in a short while. Okay, so I think lots of people have already logged in. So let's start the session. So today we are going to summarize the entire triangles chapter, and if at all you have any specific requirement, then you please enter that in the chat section, so that if not in the live class, we can definitely take that up in, let's say, we can take it offline. So now. Okay, so in triangle chapter, if you see, there are three broad categories of, or let's say there are three topics which we have learned. So this is triangles. So in triangles chapter, if you see, okay, sorry for the glitch, guys. So here we start. So basically, triangle chapters, if you see, is categorized, or you can actually see there are three broad category of topics. So the first part, we dealt with something called basic proportionality theorem. Basic proportionality theorem. Then we have this is also called Thales theorem. So if you know, we have discussed this in the class. So Thales theorem. So this is the second part of it, and then we had similarity criteria. So if you see, we had similarity of triangles, similarity of triangles, and the criteria related to that. And then third part is Pythagoras theorem and its application. Pythagoras theorem, the age-old Pythagoras theorem, and problems related to that. So this is, in a nutshell, problems related to these concepts. Okay, so in your board paper, whenever you get to see any triangle or geometry related question, so if you know that in your board syllabus, geometry has two subparts primarily, where one is questions related to triangles would be there, and second one is circles. And there could be questions which will be requiring you to know both the concepts, and the same question you could have applications of both the subtopics. So today we are going to discuss what all did we study in triangles, and how to approach problems whenever you're going to face these in, let's say, in your board paper or mock papers in the days to come. So whenever you see a geometry problem, then you know that these are the concepts which are going to be implemented there. Now, questions related to ratios, so hence these are the catchwords you have to be sure of. So ratios, then there is if you see parallel lines in problems, let's say in a given figure there is there's a figure, and there is a triangle, there are two triangles like that, and then one parallel line is this, another parallel line is this, like that. If you see such kind of a figures, let's say this is A, B, C, and D, and E, F, G. Let's say this is a figure given, and something related to this figure, there is a question which involves ratios, parallel lines, or maybe let's say square terms. Square terms. This is how you should be knowing. So square terms, let's say they'll ask you, let's say AC square is equal to BC into CD and things like that, whatever. So whenever you see such kind of relations to be proved, you know that this has got to do something with triangles, and either of these three concepts, either Thales theorem, similarity of triangles, or Pythagoras theorem would be applicable. So keep that in your mind. Now let's go and revise all the basic theorems and results which you must be having in your mind before attempting all these questions related to triangles. What we have done is we have compiled all the major theorems which are there and the results which are there and which are useful for triangles chapter. And later on, you can get these slides for your own reference. And we have also planned separate sessions on problem solving, which will be which are being recorded right now, and they will be uploaded on our YouTube channel, so you can always reference the problems offline. So let's begin. And this is, yeah. So basically, we are going to deal with triangle summary. So this is the first slide. So basically, there are 30 slides. We'll try and complete as many slides as possible. And if possible, we are going to complete the entire revision today itself. So first slide is two figures having the same shape but not necessarily the same size are called similar figures. We'll run through these concepts. We know that two circles are always, give me a moment. Yeah, so two circles are always similar. Why? Because if we have two circles, we have, they are similar. We know that two circles are always similar. So all congruent figures are similar, but the converse is not true. That means if there are two congruent triangles or any two congruent geometric figure, they will be similar, but the vice versa is not true. Why? What is congruence? Congruence means if all the angles and all the sides, corresponding angles and corresponding sides must be equal. This is my congruence. So this side is equal to this side is equal to this side, and this side is equal to this side, and all the corresponding angles are equal. Then we say that the two figures are congruent. But for similarity, you just need scaled one geometrical figure scaled down or scaled up vis-a-vis or with respect to the other one, right? So that's similarity. So hence all congruent figures are similar, but the converse is not true. So these two triangles might be similar, but they are not congruent. Why? Because the corresponding sides corresponding angles are same, but corresponding sides are not equal. Corresponding sides are not equal. So hence, if you see, this is ABC, and this is DEF, this is DEF, then AB is not equal to DE. Okay, so though they are similar, but they are not congruent. So this is point number one. Next is, yeah, two polygons have the same number of sides are similar if. So this is the criteria for similarity. If you see, so this is the criteria for similarity. Two polygons having the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional in the, that is in the same ratio. So we'll start with our triangles only. So let's say this is ABC, again same thing, ABC and DEF. Then these two triangles are similar. These two triangles are similar. Only one condition is, first of all the corresponding angles should be equal. So angle A must be equal to angle D, angle B must be equal to angle E, and angle C must be equal to angle F. This is criteria number one. And criteria number two is AB upon DE is equal to BC upon EF is equal to CA upon FD. This is criteria number one, criteria number two. So if both the criteria are met, then two given, this is, I have shown it for triangles, but it is same, it holds similarly for any other polygon as well. So corresponding angles must be same, and corresponding angles must sides must be proportional. This is the criteria for similarity. Next, so let's go to the next slide. It says, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. So this is nothing but Thales theorem. If you remember, this is nothing but if a line is drawn parallel to a triangle. So let's have a triangle. So let's say I have a triangle here, triangle, and this is ABC. This is Thales theorem. So, or basic proportionality theorem. So this can also be written as, this is my basic proportionality theorem, right? Or it's also called Thales theorem. Whenever while solving the problem, if I have seen that many of you write just BPT, that's okay, but then whenever you are using the theorem for the first time, you should, it's a good practice to always mention the acronym which you are going to use later on. So this is a common practice. Now what does it say? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, that means, let's say if I draw a line like that, then the other two sides are divided in the same ratio. Let's say this is D and E. So we know by BPT, what does it say? AD upon DB is equal to AE upon EC. AE upon EC. And I'm not going to the proofs of it, but I'll just tell you the the basic way of proving it. So basically, you have to join DE and drop perpendicular from E to, let's say, this is perpendicular dropped from point E on side AB, which is, let's say, D. And then, if you remember, we used the concept of area of triangles to, you have to join this as well. So, and then you have to drop a perpendicular like that. So if you see what was the, I'll just give a brief hint of what exactly the proof was about. So basically, we found out that we took, first of all, triangle, ratio of triangle, area of triangle AED over triangle BDE. Now these two triangles, this is area of, we are trying to find out the ratio of the area. Now in these two triangles, base is, the height is same, ED is same, and hence this was equal to nothing but AD upon DB. Why? Because this will be similar. The triangle area was nothing but half into base into height. Height is same, so it is reduced to ratio of only the bases. Similarly, you have to take the other triangle. So that is area of triangle ADE, area of triangle ADE, is equal to, let's say, 1 upon 2 pi. So this is 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 1 divided by area of triangle DCE. DCE. Here also, if you see DCE, here also the ratio will be nothing but AE upon EC. Why? Because the heights are same, so it will be in the ratio of their bases. Now, if you see triangle ADE, triangle DCE is this triangle, this area. This area is equal to the area of this area. Why? Because the base is same. D is the base for same, and they are between the same parallel line. So hence, from that logic, area of triangle BDE is equal to area of triangle DCE. Hence, these two ratio become equal. So hence, that is how it was proved. So this is a brief proof for. Okay, next. So let's go to next slide. Oh, it seems some screen is not clear. Okay, let me just check the settings once. Just a minute. Okay, screen is not clear. So just a minute, guys. Give me a second. I'll just try and fix this. Okay. Give me a second, please. I'll just fix it. Give me a moment. Just bear with me for a second. Actually, to reduce latency, we had done some tweaking, but never mind.